Good morning, everyone. Welcome to DC Summit 2022. This is Fed 204. The session title is Integrating SaaS Services with AWS, and how do you orchestrate data movement between SaaS applications and AWS. My name is Harsha. I'm a solutions architect at AWS. Joining me on stage is Satish Penmetsa. He is a principal solutions architect at Fannie Mae. So here's the agenda for today. We will be talking about the data integration challenges that customers like Fannie Mae are facing, and how AWS AppFlow or Amazon AppFlow helps with these integration challenges. That is number one, and then going into the details about the features of AppFlow and some of the customer use cases where you can use this as an integration agent, and then further processing of data that is moved from SaaS applications into the AWS ecosystem. How do you integrate that with event-based architectures with EventBridge integration? And then finally going into the implementation of Fannie Mae's use case. All right, let's start with the use cases. So working backwards from customers, that's what we do at AWS. We looked at some of the integration challenges. A lot of customers have SaaS-based applications like Marketo, Salesforce, Slack, and many other SaaS vendors. So you have data that is already residing in SaaS applications, and then you are building net new integrations in AWS. That poses a lot of challenges. For the most part, it is how do you, when you have data silos, both in the, let's say you have a data lake on AWS and you have to ingest data from these SaaS applications, how do you integrate those and make sure you are innovating with your data transformation? That is step number one, the challenge number one. And then to modernize self-managed aging integrations. The problem with the second one is, for a majority of the time, customers, especially developers, are required to develop custom code in order to build these integrations, right? Let's say you have data in Salesforce and you need to ingest that into your data warehousing, let's say Redshift. How do you integrate those two? Typically, you would have to build some sort of a custom code and basically make an API to Salesforce and bring the data in. So, which is basically a heavy lifting for all the developers who are managing these custom connectors. And the reason why this is heavy lifting for customers is not only you have to build the code and the integrations and make sure whenever a SaaS integration partner changes the APIs and the mechanisms of using those, you would have to go bake that into your custom code. Also, some of the complications with custom code is you would have to maintain a code base and integrate with your CI/CD pipeline. And most likely, you would have to have some sort of a compute infrastructure to maintain that code base, right? So that is the challenge number two. Next is, as you are pulling the data from external SaaS applications into the AWS ecosystem, you have to worry about making sure the data is pulled through a secure channel, like a TLS 1.2 encryption. And as you're pulling the data, you have to make sure the data is encrypted at rest, right, with some sort of an encryption methodology. That is also a challenge that you have to address if you're maintaining custom connectors. The next is, again, breaking down the silos. A lot of customers are doing that, and you need to make meaningful insights in a faster manner. For example, let's say you have a new sales event. There is a new sales lead, and you want to action on that sales lead. As you input these variables into Salesforce, you need to be very agile in the way you're consuming the data, either real time or near real time, and have some sort of a dashboarding feature. So that is another important event that you need to look at is how do I create dashboarding events that is event driven, like whenever somebody on the sales organization creates a lead, how do I ingest that lead quickly as soon as possible into a dashboarding service and then action on it. So that is what we're talking about here. And then operating costs for any custom connectors, if you have worked with any of those, either third-party custom connectors or in-house developed custom connectors, that obviously has a cost element to it. That is another thing that the customers are worried about, is controlling costs on these connectors. And then finally, to connect these applications and processes, you need to do some sort of automation, gluing these different services and also stitching these different components together in order to make it into one cohesive workflow. These are the challenges that we heard in the field. And an answer to that is Amazon AppFlow. How does Amazon, what is the use case here and how does that help? It is, Amazon AppFlow is a newer AWS service that is built for integrating, it's basically an integration service between SaaS-based applications to the applications that are running on AWS. Now, preceding to this, I was explaining to you the challenges with developing custom connectors and maintaining the code base. The promise of AppFlow is it is a low-code, no-code option where you don't necessarily have to spend developer cycles to maintain integrations with the SaaS providers. This comes out of the box. It's very intuitive, very easy to use in terms of configuring these connections without actually having to maintain a code base. So step number one. Next is cost savings. Because you are not using any third-party integrations or third-party connectors, you don't have to pay any licensing fees. This comes out of the box. This is pay-as-you-go. As based on your number of connections, you are going to pay for whatever you use. Much like the rest of the ecosystem of AWS managed services, you're not maintaining any infrastructure. You don't have to worry about networking. You don't have to worry about data encryption, whether it is encryption in transit or encryption at rest. These are all out-of-the-box capabilities. Speed and agility, at the end of the day, you're trying to solve a business problem, which is as soon as an event takes place in your SaaS application and you want to ingest that event into your AWS ecosystem, or vice versa, you have an event happening in AWS and you want to push this event-based trigger into a SaaS application, this bidirectional data flow is what is AppFlow enabling you to. And then finally, as I was explaining, it is secure and scalable, secure with respect to encryption, but also there are certain SaaS providers with which this service integrates using Private Link. For the folks who are not familiar with Private Link is a networking capability on AWS where you can privately connect to other SaaS applications without actually leaving the VPC, so you don't have to go over the internet. This is something that you can privately talk to. So let's go into the details. How does it work? What is the advantage of the service, and how do you actually implement this service? So as I was telling you, this is a fully managed integration service, and it is pretty intuitive. There are 3 ways to interact with the service, much like any other AWS service. You have the CLI method, you have the SDK, the software development kit, or you can use the Amazon console. It's pretty point and click. You don't have to do a coding at all. So essentially what you do is, in step number 1, you are going to create what we call AppFlow flow. So as you create a new flow, you will be defining the flow requirements in terms of is it upstream dependency or downstream dependency, meaning are you trying to pull data from a SaaS provider or trying to push data to a SaaS application. So that is what you have to figure out as step number 1. And once you do that, you go through a series of clicks just to make sure you're configuring the AppFlow correctly, which is you are creating the flow and defining the flow source, and then what is the target for that source. So basically, you're facilitating data movement from one place to another. That could be a SaaS platform to S3 or SaaS platform to Redshift, or alternatively, maybe you have data ingested into S3, and now you did some sort of a data massaging, and now you want to, after enriching the data, you want to push it to a SaaS platform. Either of those 2 cases can be satisfied with this service. So once you do that in terms of defining the flow itself and the requirements, you are going to execute the flow, and there are 2 or 3 different series of executions that you can do, and we'll be walking through that. And here is an example of the connectors. So today, Amazon AppFlow, you can integrate to external SaaS applications, as I was telling you with AWS. And here is an example connectors, SaaS applications, either Marketo or Salesforce or SAP, Google Analytics, Slack. These have different use cases based on your own external dependencies for your applications. If you're doing event-driven architectures today, and if part of your architecture has these dependencies, then it is pretty straightforward in terms of configuring Airflow. So what you're doing here is, as I was explaining, there is bidirectional data flow that you can configure. But for the sake of today's session, we will be talking about how do you ingest data from external SaaS into AWS, not necessarily triggering a downstream push. But you can see on to the right side that once the data is pulled in from external sources through Airflow, your target is either AWS or third party, but we're not going to be talking about that third party today. All right, so as of today, there are about 23 connectors that are supported, and with respect to sources, and with the same with destinations, there are multiple destinations. We will talk about some of the best practices from an architecture perspective. How should you be configuring these connectors? So the screenshots that you see below is basically a walkthrough on how these connectors are configured on the AWS console, but focus on the top boxes. So the first one is, as I was explaining, you would go create a Airflow flow, and that is where you are going to select the source and destination login. So what this means is, if you have a authentication, obviously you have to authenticate against a SaaS application. So maybe you have some sort of a token, a authorization module through which you authenticate through an API. This API could be a Salesforce API or Slack API and things like that. So first step would be to configure that connection itself, like the connection string. If you're familiar with databases, the way we connect to databases using JDBC with a username password, pretty much that's how you are doing. But in this case, it's not necessarily a username password. It is usually some sort of a session token that you are authenticating against. So you are going to get that session token from the SaaS application and use that as part of the connection initialization in Airflow. And once you do that, once you get authenticated and get the session token, then you will proceed with the next steps, which is how do you want to trigger the flow? Is it event-based, like I added a new sales enablement, maybe I found a new sales lead. At the moment I add it into Salesforce, do you want it to automatically send that data to Airflow? That is what the event-based programming model is. The second one is scheduled. Maybe you don't necessarily need that event-based. Maybe you want to do that as a batch ingest, and you want to do that in maybe a scheduled manner. So that's what you can do. The lowest frequency is 1 minute interval, and you can go into, like, maybe you can run as a hourly job or at the end of the day aggregation or a monthly or a quarterly aggregation. It's up to you. And the third option is on demand. So this is something that is very interesting for, let's say, data scientists, and you are doing some sort of data analytics job, and you want to pull the data from the third-party SaaS applications, and you want to do it on a one-time basis, maybe ingest into data lake and run your machine learning or whatever algorithms that you want to apply against that data set or enrich the data. That is what you would do for on-demand. So all three are supported today. Once you configure your trigger, next is how are you going to map the source and destination fields? Let's say you have a schema that is on your data lake. That schema may be different from the source schema that is in Salesforce. So instead of doing ETL processing like the way you would do it traditionally, you don't need to do that ETL processing or an ETL engine to do that. To change the schema from one to another, what this gives you is an option for you to map the fields from the source and the destination. Let's say you want to aggregate, there is sales data pertaining to some items. You can aggregate those items into a hyper field where multiple fields are collapsed into one. So you can do some enrichment like that. In addition to that, so after mapping the source and destination fields, the next is to add filters. This is also extremely important because if let's say you are ingesting sensitive data like PII data, Maybe you have social security data in your Salesforce or or some other phone number or address, anything that you deem as PII. And if you want to ingest that data in a secured manner, it is very common practice to mask this data, right? Maybe you don't want to reveal your SSN to the data analyst. The way you do that is you mask the field level like tokenizing a portion of it by masking maybe first 5 characters and just leave last 3 characters, right? That type of filtering and validation and transformation can be done using Appflow. In addition to masking sensitive fields, you can combine, as I was explaining, you can aggregate multiple fields into one, so you can do these data aggregation jobs as part of your flow creation itself. You can also truncate fields if that doesn't match your destination schema. So once you do that, you activate the flow, you will see at the end everything is ready to go. And based on the configuration, now you can test either on demand or on a schedule, or maybe you want to create an event and see whether the flow is actually working and you're ingesting the data. With respect to the integrations, so let's talk about this. As I was telling you, there are about 23 partners with which Appflow is integrated today. What is important for you in terms of the destination is focus on the destination, the AWS services at the bottom. As you're ingesting this data, as I was explaining, this is TLS encrypted in transit and KMS encrypted at rest. So by design, by default, it is a service-owned KMS key. But if you choose to use, let's say you have a project where that project has a dedicated KMS key for encrypting the data, you can use that KMS key as part of the configuration itself and to encrypt the data. And accessing the destinations like S3 and Redshift, what we recommend is if you have some sort of a VPC endpoint for S3 or Redshift, that is something that you should configure. And if it is configured, then the transmission of the data from Appflow to your destination bucket is flowing through that private link. And if it is enabled for private link, the advantage there is now you can intercept that data and make sure you are putting governance control on the flow itself. Is it going to the right destination bucket? Does it match my security posture? Maybe this is something like NIST. This is an application that is sensitive enough for meeting NIST compliance or FedRAMP compliance and things like that. When you want to overlay that security and compliance regime on top of this entire end-to-end workflow, you want to make sure that that connection itself is private, and you want to enforce certain guardrails with the way the data is traversing your VPC endpoint. So that's what the endpoints are going to get used for S3 and Redshift. With that, I'm going to be transitioning into, now that you know about the Appflow itself, let's look at how Fannie Mae has taken this capability to solve their business challenges. With that, I'll welcome Satish onto the floor.
Thank you, Harsha. Welcome, everyone. Good morning. My name is Satish Penmetsa. I'm a principal architect at Fannie Mae, and I support the single-family portfolio architecture. Today, we'll be sharing with you our journey on how we use Appflow and the serverless data integration stack. To start with, some of you might know Fannie Mae, and how many of you have heard of Fannie Mae? Quite a few hands. Trick question for you. How many of you know what an MBS is, mortgage-backed security? Well, there are some brave souls there. Well, a lot of you know that. But I think for the folks who actually probably don't know what Fannie Mae is, I'll just spend a few seconds explaining the business context so that you can better appreciate our technology problem. And I promise we'll get into the architecture and the meaty stuff pretty soon. So Fannie Mae is a pretty large organization. It's a $4 trillion financial organization. To get a sense of how much financial transactions flow through in 2020, $1.4 trillion in liquidity was provided by Fannie Mae for the housing market. And 1 in 4 single-family homes that were either you took mortgage for or refinanced went through the Fannie Mae's process. So that's how big it is. Our mission at Fannie Mae is to provide affordable and equitable and sustainable home ownership and housing finance, and also rental housing. Now, what does that really mean? What does affordability really mean, right? So I want to share a personal story of mine on how I appreciate this process and why such an organization is important and how the mission is important. So I come from India, where my parents lived in India, and I remember when I was a kid, my dad and my mom always dreamed about owning their own house. And my dad worked throughout his life, saved his money in something pretty similar to 401k over here in his pension fund, right? And it probably took him around 15 years to save that money and eventually buy a house. And I remember he was so proud, his shoulders were so proud, and my mom was so happy living in this house. So it was really a dream for him. But it took him 15 years, right? Why was that the case? Because of availability of credit and also the ability to pay the loan over a long period of time. Now I'll switch the narrative a little bit on my story, right? I was lucky to have a good education. Thanks to my parents, I was here, I had good credit worthiness, and when I got married and I and my wife wanted to start a family, we definitely wanted to buy our own house. It was our dream, right? So we were able to plan for up to 2 to 3 years, save 10% of the loan that we have to deposit, and luckily for us, in like 4 or 5 years of planning, we were able to afford our first house. Now, the product, 30-year fixed mortgage product that Fannie Mae supports is the key here, right? So you have a long-term loan, you have a predictable payment, right, toward the life of the loan, and you have peace of mind. And that's what really affordability means. And hopefully that resonates with you. I come to appreciate that, the way, thinking through that way, right? Sorry about this. I think this is a good slide to look at how, some of you out there already knew what an MBS meant. But just to explain how Fannie Mae works, how does this magic work, right? Really, how can somebody afford to keep giving loans, and how can that be really 30 years, right? The way that process works is borrowers get loans from the lenders. Lenders are primarily mortgage lenders are primarily our customers, Fannie Mae customers. Then they sell these loans to Fannie Mae. Fannie Mae then packages these loans as sets of loans which are with a similar quality, and we call them as mortgage-backed securities, and really sells them in the securities market as bonds, right? And investors invest in these bonds, and the cash flows back. So that's a nice cyclical cash flow, and that's really how this magic works. Hopefully you appreciate this process better. I want you to focus on a couple of things over here. One is, for today's use case, what's important for us to know is that we are largely a B2B company. What I mean by that is a business to business. Lenders are our primary customers, right? We don't directly interact with borrowers, although there are some interactions, but from a business and systems integration perspective, lenders are our customers. And as part of our journey, our customer management journey, we transformed our customer relationship, customer service, marketing, all of the customer management capabilities, and we chose a fit-for-purpose platform. In our case, we use Salesforce for that, right? And there is this bidirectional data need for us to push data from our CRM system into our backend systems. The reason why we need that is, if you remember the business process, right? Our downstream systems, which are our transaction systems, when we purchase our loan, we have eligibility requirements, right? We have strict selling and servicing guidelines. So our customer agreements, our customer account statuses, our customer relationship data all lives in Salesforce. So we need to be able to bring that down to our downstream processing and our core transactional systems. At the same time, as part of our customer transformation, it is key, and it's very important for us to get the data that's in our data lake, the insights that we have of how much volume a particular customer is delivering to us. All of that insight data has to be actionable and should be available in our CRM. So we want to be able to push that data. When we push it, we also want to automate it and create actionable activities for our customer relationship folks. So we touched on that. The other key thing that I want to touch on this is that our CRM tech teams, these are teams that we invested on. They're primarily experts in our CRM tech stack, right? So they're pretty new when we started and embarked on this journey. pretty new to AWS. So we're looking at technology and solutions where solutions provide that lift for our technology teams. We don't want to end up spending a lot of time on provisioning and managing the tech part of it and really focus on something that's core to our business. So that's other important aspect to this problem. Now, this is where you can take a look at how our technology footprint is, right? Prior to we transforming this, the way to read this is on the left-hand side, obviously we have our CRM system, our data center at the center, and on the right-hand side, you're seeing the AWS accounts that we have, right? There's a lot going on here, and I will unpack this for you. One is, as part of our cloud migration journey and cloud transformation journey, we have heterogeneous systems, right? We have systems that are legacy, things that can interact only with files. They don't understand APIs or modern eventing, right? So there is file-based integration that's going on. And these systems are on-prem, and there are also some of these things are also migrating to cloud as part of our cloud journey and cloud migration strategy. There are systems that integrate using APIs, so we need to be able to support APIs and integrate with API mechanism. There are also systems that use eventing, right? So we have message-based systems using JMS, message buses on-prem, and we need to be able to support not only just the future state of how these systems will interact, right, when they migrate to cloud, but also the near term, what we call the interim state, is as these things are moving to cloud and the data gravity is moving to cloud, we also need to be able to enable the interim state of being able to connect to the on-prem as well. Hopefully that makes sense to you. So that's our current problem. Now, a lot of the data integration stack that's here is either on VMwares or in some cases physical infrastructure. We have a database, right, RDS or Oracle database that we use, and we have an integration layer which is a custom COTS product that provides us connectors to Salesforce, right? It also provides connectors to file system, it provides connectors to JMS, and also API. So we have all of this infrastructure and the third-party tool. So when we started looking at options to move to cloud, our first thought was, could we just do a lift and shift, right? Could we just take this and move it to cloud, lift and shift, and maybe install it on EC2? Wouldn't that be just speed to market? We could just go there really fast and we're done with it, right? When we started going down that journey, we realized that what's the benefit of doing that, right? What would we get out of that? We still have the problems of patching the OSS, dealing with gaps in our security in terms of things like access tokens that Harsha was talking about. Are those access tokens rotatable automatically? Are they saved in a secure location? So we still had to have shortcuts, right? So some of these COTS products did not natively integrate with something like Secrets Manager. So we still had a lot of lift to think about from the technology team's perspective, and we wanted to get away from that and look at alternatives where they're focusing on more on the business side and building more the data workloads. So the problem also is not just one-fold. The problem is now certainly multiplied by 4-factor or 5-factor, because we had a lot of lifecycle environments in our on-prem, right, where we have dev, test, acceptance, and prod. So our teams were actually managing the infrastructure across these environments and worrying about patching, worrying about upgrades, and anytime there's a change, scaling really becomes tough because we have to manage all of the environments, right? The next problem we have is, given a regulated company, and given we put a lot of emphasis on resilience, right? Some of the business processes that we are talking about here are core to our business. We want to make sure that we have a disaster recovery site and our workloads are duplicated across regions, and we want to be able to back up our data. So there's more complexity that gets added, right? So let's take a look at some of the key tenets. So I think we talked about all of these. One is we need to be able to solve for bidirectional data integration. We need to be safe right? Secure data, especially sensitive data, we want to be able to protect that either in transit or at rest. We want to be performant and scalable because if some of you guys have, how many of you have used Salesforce over here? A lot of you. And Salesforce has something called quotas and limits, right? So you have API limits. Now what we want to make sure is that all of our limits and licensing is accounted for our customer relationship management activity and business process. And we have downstream systems that are real-time systems. In our use case, where I can share one of the use cases, the customer access management system. It gets the account-to-account relationship data, and the way it's architected today, it can make up to 20 million calls a day. And you don't want to tax that on a Salesforce cloud. You want to have that set of licensing on APIs really be used for your CRM app and the integrations that are outbound and interactions with your customers or customer systems, right? So we want to make sure that they are scalable and performant. And lastly, I think we touched on this, is the low-code aspect of it, and providing that undifferentiated lift to our developers. Pick a service where you don't have to manage the platform level stuff, in terms of upgrading the OSs or managing the OS and the platform and the infrastructure itself. So this is a bird's eye view. I will subsequently I'll go through some of the patterns, but the high level, the overall picture looks like this. It's actually a simplified view than there's a lot more going on behind the scenes in terms of foundational stuff, but I'll explain to you some of the foundational architecture that also underpins this, right? So at Fannie Mae, we have been on this journey, cloud journey, for a couple of years now. And one of the key things that has happened is we have set up an account strategy. So we have a multi-account strategy. The one that you're seeing here is a single family BU business unit, but there are other BU accounts. Now what does this allow? This allows for not only the scalability so that your rate and quotas can now be shared across the accounts, right? It also allows for your governance and policy. You can set up at the org unit level service control policies so that you can secure and really have the vertical segmentation, the macro segmentation, right? So that's one of the foundational stuff that's going on. That's not today's talk, but just to give you guys a gist of what's behind the scenes, what's the foundation that's there behind this, right? And the other piece is also the networking piece. So we have a direct connect with our data center so that we don't have any issues in terms of the bandwidth, right? In connecting to our AWS from the data center. We have transit gateway so that the routes and the traffic between the accounts and also our data center flows through. So some of that foundational work is done. And third, of course, there's a lot of security work that is done in terms of vertical segmentation of apps, and also for north-south and east-west. There's a lot of foundational security work done. So we have integration with IAM and our Active Directory. And for example, when it comes to our on-prem systems connecting to S3, we can connect over STS, get a temporary token, right, and connect through a VPC endpoint and have that completely secure and also time-based access. So some of the foundational stuff is taken care for us. On the right-hand side, what you can see is that we also have some of the shared services set up. For example, we have an internal API gateway that also does more things in terms of rate limiting and virtualization. I don't want to get into that today, but there's also a on-prem bridge which allows for communication for event-driven systems from AWS to on-prem to just bridge that SQS to JMS, right? So we have some of the shared services set up. So with that foundation, let me just get into this and explain how the serverless architecture works for our bidirectional data needs. Harsha talked about this and how AppFlow is key to this part, right? So AppFlow is providing you that connector. So we are able to connect to Salesforce. And when you first set up that connection to Salesforce, what AppFlow does then is manages that connection, automates that connection, and also stores the secrets in the secrets manager. And it uses KMS also to encrypt the secrets. So you don't have to write the automation yourself in configuring Salesforce. That's one, right? AppFlow is also providing you two options. One is you can have the traffic go through public internet, or you can use private link. So if you're using private links, then that traffic is also privately going behind the backbone, and that's additional compliance for you. AppFlow then is also providing you three different mechanisms. I think Harsh has alluded to that, and we are using multiple of them. We are using the event-driven and also the schedule-based, because we have some legacy systems on-prem currently that they just integrate with files, and they want to be we want to be able to schedule data either end of the day or on a scheduled basis, where all of that data is available to our downstream systems. So we use the schedule flow, and we also use the event flow, where events from Salesforce are flowing down through the event-driven architecture, and for that we leverage EventBridge. And Lambda is subsequently the service that we use for either in needs where we need to enrich the data and also persist the data in DynamoDB. Now, what this does for us is the moment we persist the data into DynamoDB, now we are able to also, with just adding additional lambdas, expose that data and API to our consuming systems. I alluded to a point about the 20 million calls that our access management systems today make to our legacy systems for account-to-account relationship data or status data, right? So we can easily scale that call with Lambda and DynamoDB and not have to worry about the rate limits or API limits on the Salesforce side. So that's a high-level view of it. Let's dive a little bit deeper on the event-driven subscription pattern and look at how that works. Now, I mentioned on the Salesforce side, let's take an example of an account status change. Salesforce has an event bus, and whenever there's a change to an account, that event gets published onto the Salesforce's event bus. What AppFlow does is, behind the scenes, Salesforce uses something called as CometD as a protocol. Behind the scenes, AppFlow understands this protocol. It connects to Salesforce, subscribes to those messages, and we have a EventBridge event bus set up. The events just get automatically published there. Now, within EventBridge, you have capabilities to transform that event. There's something called as a transformer that you can configure so that Salesforce has its own nuances in how the attributes are named and also how the data types are, right? So you could change them and map to something that is more standard to you that your downstream systems can consume, right? So you can standardize that. You can use it for that. Second part is EventBridge also is fault tolerant in the sense that it supports natively retry mechanisms. So you can configure the number of times you can retry for whatever reason Lambda fails, or the time for which amount of time for which it needs to retry. And in the worst case, it also supports DLQ, dead letter queues, so your messages can go into the DLQ, and you can have an operational Lambda, and also you can notify your operations team so that they can react to any errors. So that's a great architecture, right? And foundationally, what is also happening is throughout this flow, AppFlow and EventBridge both integrate with KMS using even CMK, right? So you are able to encrypt data at rest, and also the data is encrypted in transit, so you're getting that safety, right? That security as well, and compliance is nicely met there. Subsequently, in our case, we have systems that also integrate using SNS and SQS. So this Lambda could publish messages to an SNS topic or an SQS queue, and the downstream systems can consume from that. DynamoDB, we'll talk about this in the next slide as to why we went with DynamoDB and Lambda as our choice for our APIs. So we did some analysis in terms of the data loads and our event sizes. There are certain limits that you have to be aware of. DynamoDB itself, there is a table limit, right? Even EventBridge has a limit on the size of the event message. So I want to encourage you guys to take a look at those limits, as long as from a requirements perspective that meets your need. DynamoDB and Lambda together now provide you that scalability in terms of APIs, right? You can, for Lambda, you can configure the reserved throughput and the provision throughput, and really scale the Lambdas, the calls, right, to Lambdas. And Lambda, also from a guardrail perspective, Lambdas can be connected to your VPC. So this again goes back to Lambdas cannot then go out to public internet on their own. They will be a private IPs, right? So your safety and security is increasing, and that's a great feature. One thing that you want to keep in mind is if you are doing that, do that to all of the VPCs across the AZs, right? Then that gives you the availability, cross-region availability, or cross-availability zone fault tolerance and scalability, right? So make sure you do that. So you do have that nice guardrail, and you can still be secure, and you nicely alleviate all of your problems with your rate limits on the Salesforce side of it. So that's how we solve our API use case. Next, I want to show or talk about our bulk data interface pattern. Again, like Harsha said, it's really easy to set this up. You go to AppFlow, and you can configure that a certain account data needs to come down into S3. S3 becomes your target, and you can either schedule this as a schedule basis or an on-demand basis, right? We do schedule it for an end of the day, and there are a couple of options you have there. One is you can do this as a full file for whatever reason. If you want all of the data, AppFlow can do this, or you can also do incrementals. So AppFlow does support something called as incremental updates. So the first one would be a full update, and then subsequently, based on the last date time, it can create incremental files. So you can choose to do that. And we get data into S3 not only for our legacy systems that we talked about on-prem, which need file formats, right? And again, I think one of the points to mention is AppFlow does support CSVs, JSON, and Parquet, so you can choose your formats there and what fits your need. For our downstream systems on-prem, then once we get this file, although I don't show that in this diagram, using that foundational architecture that I talked about, right, where we have an on-prem system that is connecting to S3 over a VPC endpoint through our direct connect. Nothing is going through public internet, but it's also temporary tokens, and all we have to do is just write a few lines of code, have an S3 client that connects to S3, and be able to get the file back down to our on-prem. So that way, just by having that little bit of work done, we're still able to solve for our on-prem use cases, for our near-term use cases. And while our systems move to cloud, once they move to cloud, for whatever reason they want to continue to access S3, it's just a cross-account role, right? A cross-account read from a compute resource on the other account or other application that can just access that data. So we have allowed for this nice transition of storing data in S3 so that our on-prem systems can access them, and also our cloud systems can access them in future. So the next one is really the other way around. We talked about the bidirectional data need, right? So we have data in our data lake and other systems on the cloud, where we want to provide those insights to our customer management teams, and we want to be able to automate this. The reason why we just don't create dashboards in Salesforce is because then they are not actionable. What we want to be able to do is understand insights like how much volumes that a customer is generating, other key and critical business insights and KPIs, automate that data push into Salesforce, and have a trigger in Salesforce automatically to create an activity for our relationship managers, so that this process is nicely automated. And AppFlow is allowing us to be able to do that. This is what we did with our legacy footprint. Now we are able to just transform that using serverless. And some of the things that I want to touch upon, key things I think we talked about throughout this talk, is that key things is safety, security, and efficiency, right? From a safety perspective, things that come to my mind is there is that nice integration for AppFlow with Secrets Manager, right? Historically, we had some gaps there. There is integration with KMS, so data at rest is taken care. The other piece that I probably missed mentioning before is You remember the recovery and the resiliency aspect where we have out of region site. Two good things are happening. One is DynamoDB has global tables, right? So when you insert in one region, automatically data is available in another region. What we do is we deploy our workloads in both places, and AppFlow actually is not actively running in another region. For whatever reason, this region has to be shut down. All we have to do is then enable, activate the flow on the other side, and within minutes we have our other workload running, and we don't have to worry about the data, copying the data over ourselves with the global tables, right? And also with S3, we do cross-region replication. So if there's any files that are in the primary region, we also have access to that data in the other region using cross-region replication. So we've taken care of resiliency. We talked about performance, right? We are able to really use Lambda and DynamoDB for its benefits and configure them so that we can scale up the API calls, and also the response times. I don't know if I mentioned, but it's sub-second response times that we can reach with these API calls. And I think one of the things that has been a nice side effect for us is the CapEx versus OpEx. When we dealt with tools, third-party tools, we often ran into a situation where we had either a multi-year contract with a connector, and suddenly we don't find use for it, and you can't really get out of it. You can always buy more, but you can't buy less. So that's the other challenge. And when we were going into cloud, we realized that certainly S3, SNS, and SQS, these are all new connectors. So hopefully, that's a summary of it. Hopefully, you enjoyed this talk, and I would now, with that, hand it over to Harsha.
If you have any questions, please, again, we'll be available in the hallway if you want to have a follow-up conversation, but also, get the next slide. Just to close it out, again, this is if you're interested in learning more about AWS skills or get certified, here are the links for you. And again, we request you to please provide your session feedback. And again, like Fannie Mae has solved this problem at scale, so please pay attention to some of these patterns, and something that we look forward to you implementing in your own organizations. Thank you all for joining.